Welcome to experiment 6. This is the ROM. Now in the MicroMaster, we're lucky because it's not just a read-only memory, it is a double EEPROM. That is, it's a ROM that we can actually write into by special commands. We've added the 2816, we've added the buffer or latch chip to hold its address data, plus the various switches to enable the ROM and to disable the write. The disabling write switch or write enable, if it's in the down position or off position, will not allow the CPU to write data into the double EEPROM. So normally once we've got a program in there we want, we're going to leave this switch in the down position. The ROM enable switch, they call it NROM, is normally going to be in the down position, except when we're pretending we're the CPU, because we don't have a CPU in yet. When we flip that switch up, then the chip select on the ROM chip is going to get turned on, and that's going to enable us to read and write information on the ROM. So when we power the system up, we're going to leave both those switches off. And let's walk through writing some information in this to test it. So first of all, we're going to do the write enable, turn that on, so now we can write data into the double EEPROM. We're going to flip the ROM enable switch on, which makes the pretend CPU activate the chip enables on that chip. Now we're going to put address 0 out on the bus, just like before, activating address latch enable. So now the ROM has the proper physical address on its pins that we wish to read or write. Now at address 0, we're just going to turn on a single LED and press the write button. We'll go to the next address, which coincidentally will be address 1, latch the address, and in address 1, let's just turn on the next LED. Okay, address number 2, we're latching the address, and in address number 2, we'll turn on the next LED and write that back into the double EEPROM. Now if you're with us so far, we've simply written data into address 0, address 1, and address 2. So let's see if we can recall that information. So here we are at address 0, latching it and reading it, and you can see our LED is showing up. Address 1, latch, and read, you can see the data is showing up that we put in there before. Address 2, latching, and reading, again you can see that distinctive pattern. So you should try this for several memory addresses just to make sure that it's working correctly. Now on a different machine, I had programmed some other information into this ROM. For example, at address 10000000, I programmed part of the ASCII character set. So I'm simply going to load that address in. There's the data, 41 hexadecimal. So that's the letter A. At the next address, I had programmed the letter B, and there is 42 hexadecimal, the letter B. Now, when you're done working with this, turn the write enable switch off. You should be able to turn the power off to the board, turn the power back on, with all the switches down, latch that address in, and you can see that the ROM is indeed holding the data. It is indeed a non-volatile memory. That is, it's keeping its information when the power's off. That's important because in the next experiment, you're going to load the monitor program into the ROM. Actually, we're going to do that for you, and then you're going to use the monitor to write a simple program into the RAM and execute it. So anyway, that is experiment 6. If this is working for you, great. If you have any questions, let us know.